Welcome to another edition of Comet Algebra. I hope your summer is going just fantastic for you. And I'm sure that sitting down to watch these Algebra 2 videos are an absolute highlight in your summer. So this is the video to go with the page in your summer packet entitled Section 1.7, Compound Inequalities. Let's go through a quick review here of these two terms on the table, conjunction and disjunction. Now we covered these in A1, but I think it's worth a little bit of review. Since we're going to be solving two inequalities at the same time, we have two different solution sets to consider. In the intersection, in the conjunction, which is described by the word and, you're looking at the two sets of answers and where they overlap, where the solutions are that make both of them true at the same time. The other possibility is the disjunction, or the or, and we've referred to this as the union. So this is when you find two sets of solutions and you want to combine them both, because it's one or the other. Another way to say that is where either are true. All right, I hope that's enough to refresh your memory. So let's try these in a couple examples. So in this first one, we have an and situation where we need to solve both of these, and then we will be looking at combining their answers to see where they overlap, where are the solutions that make both of them true. So now just solving this, start by subtracting a 9 from both sides, and then dividing by 5. So the first part of this example is x is less than or equal to 3. In this one, start by adding a 7 to both sides. And since we're dividing by a negative, recall we need to flip the inequality, so it becomes x is less than negative 7. So now I think an easy way to look at these solutions to see where they overlap is to graph them on a number line. So let's graph the first one of x being less than or equal to 3. So since this is a less than or equal to sign, recall we need a closed circle. So we're going to come over here to a positive 3 and put a closed circle. And then to represent everything less than that, the arrow would go in the negative direction. Now to graph x is less than negative 7, go here to negative 7. It does not include negative 7, so that means an open circle. And again, going off in the negative direction. Now I'm going to graph the final answer in blue. When I look at where these two overlap, it would be starting right here, just not including negative 7, but starting just after that. So the overlap is like here and here. So the final solution with the and joining them is an open circle on negative 7 and the arrow going off in the negative direction. So this blue represents the final solution of both of these inequalities, where they intersect, where the solutions satisfy both of them simultaneously. All right, in example 2, we see we have a compound inequality, but there's no word like and or, and there's no symbol like the V for union and the upside down V for intersection. There's nothing to go on. But we just understand when they're written in one inequality like this, in one math sentence, we understand that this is an and problem. This x has to satisfy both of these simultaneously. This has to be in between 8 and 18. So we go ahead and solve this, and when we do it, we just kind of take 1/2 at a time. So for the first part, my eyes are just going to look at this part. So we'll start by adding a 7 to both sides, and then I get 15 is less than 5x. Divide both sides by 5. 3 is less than x. Now, my brain has a hard time seeing this when the x is written on the right. So when I'm going to graph on a number line, I prefer to rewrite this as x is greater than 3. Now these are equivalent, but this one just makes it easier for me to see. So now coming back up here, now I want to look at the other part of this inequality. Now let's just look at this part and solve that. So start by adding a 7 to both sides, and I have 5x is less than 25. Divide both sides by 5, x is less than 5. So now I need to graph these two inequalities on a number line. So first I'm going to graph x is less than 3. I'm sorry, x is greater than 3. I can read. Open circle on 3, and greater than would be going off in the positive direction. Now let's graph x is less than 5. Open circle on 5, and less than going off in the negative direction. So once again, we know this is and. We're looking for the overlap for where the solutions satisfy both of them simultaneously. And I can see my overlap is right in here. So when I graph my final answer in blue here, we have an open circle on 3, an open circle on 5, and it's only the values that are in between here. In between 3 and 5, but not including 3 and 5. Try that again. All right, so that's the solution set for example 2. In example 3 here, we have an or joining these. So or means all together. We want all of these answers included with all of these answers. We want the union of these. So we're going to solve them separately and graph them on a number line, and then all of the answers will be included in our final solution. So for this part here, subtract a 6 from both sides. 9x is greater than 54, and then divide both sides by 9. X is greater than 6. Here we have a little more work to do. We start by distribution. Negative 2x minus 14 minus 3x is greater than or equal to 11. Combining like terms here, we'll combine the x's, and let's go ahead and add a 14 to both sides. So we have a negative 5x is greater than or equal to 25. Now we need to divide both sides by the negative, remembering that that does flip our inequality. So x is less than or equal to a negative 5. So now let's graph both of these on a number line. All right, let's first graph that x is greater than 6. So we come over here to the 6, open circle because it is not included, and greater than is going off in the positive direction. X less than or equal to a negative 5, coming over here to negative 5, close circle because it does include the negative 5, and an arrow going off in the negative direction because it's less than. So going back to my joining word here of or, the final solution is this. It's both this graph and this graph because the answers could be here or here. All right, that concludes 1.7. Have fun with that section of your summer packet.